Tonight's lesson is lesson 79, and we are doing finding equivalent fractions by multiplying by 1. So equivalent fractions are different names for the same number or the same fraction. They just might look a little bit different. For example, we have 1/2, and the same fraction can also look like 2/4 because we're out of 4 pieces and we have 2 of them, which is the same as 1/2. Or we have 3/6 right here, which if we had a pizza out of 6 pieces and we had 3 of those 6 pieces, we would still have 1/2. And then if we had a pizza out of 8 pieces and we had 4 of them, that's exactly 1/2. So fractions can be the same, be equivalent or equal to each other, but they might look a little bit different. So to find equivalent fractions, we multiply a number by different fraction names for 1. Okay, so we're multiplying, just like if you were to multiply 5 times 1, it would still equal 5. Well, we can do the same for fractions, just our 1 isn't going to look like a 1. For example, we have 1/2. Now we're going to multiply it by 2/2. You know that 2/2, I'm going to draw like a 1, is really equal to 1. And then when we multiply across, like we've learned how to do, 1 times 2 is 2, 2 times 2 is 4, and you can check your answer. If you have 4 pieces and you have 2 of them, you have 1/2. So what we do is we multiply by 1, but our fraction could be a 3/3, a 7/7. Remember, one whole is having your denominator and your numerator exactly the same. So I did another one, 1/2. And I want to find an equivalent fraction, or a fraction that's equal to 1/2 but looks a little bit different. And I multiplied it by 3/3, which this really is 1. 3 times 1 is 3. 3 times 2 is 6. I had 6 pieces, and I had 3 of them, which is equal to 1/2. And I did it again. I multiplied by 4/4 because this really equals 1. And when you multiply, 4 times 1 is 4, 4 times 2 is 8. It is still equal to 1/2. It just looks different. Alright, we're going to try the first example. And it says, what name for 1? So, you know, we've been using 3/3 as 1, 5/5 as 1. So what name for 1 should 3/4 be multiplied by to make 6/8? So, what we want to do is we want to multiply 3/4 by a number, and we want to end up with 6/8. And these are equivalent fractions. So our numerator and our denominator are going to be the same because we're using a different name for 1. We just need to figure out what our fraction is going to be that's equal to 1. Well, I like to look at my denominators always first. And I'm thinking, okay, 4 times what number is going to give me 8? Well, that one should be an easy one. And I put 2. And since this number right here is equal to 1, if I have 2 on the bottom, I have 2 on the top. Then you can go ahead and check your answer. 3 times 2 is 6, 4 times 2 is 8, and I multiplied by 1. So 3/4 and 6/8 are equivalent fractions. They're the same fraction, they just look a little bit different. And this is how you're always going to change the value. When you multiply by 1, you don't change the value of the number, you just are changing what it looks like. The value is still the same, it still means the same, it just looks a little bit different. Alright, the next one. Write a fraction equal to 2/3 that has a denominator of 12. Okay, so what we're doing here, we need to write a fraction that is the same as 2/3, but our fraction that is going to equal that is going to be have a denominator of 12. So basically, 2/3 is equal to what over 12? And now these fractions are going to be the same. So kind of like the problem before, we need to figure out, okay, what are we multiplying by that is equal to 1? So we're not changing our fraction, we're just changing the way it looks like. We're not changing the value, just what it looks like. We can change the name of a fraction by multiplying a fraction by 1. So if I look, I'm going to set it up like I did the problem before, and I have 2/3 times a number this is going to be equal to 1, and it says I want my equivalent fraction to have a denominator of 12. I don't know what my numerator is yet, but that's okay. So I have to look and I have to say 3 times what number is going to give me a denominator of 12. And again, this is, something that we've been practicing a ton this year. So we should just know automatically that 3 times what number is 12, automatically know that's a 4. And when we're dealing with equivalent fractions, again, we always multiply by 1. So if I have 4 on the bottom, my denominator, I need to have 4 on the top. And now I can multiply across. 2 times 4 is 8. So 2/3 and 8/12 are equivalent fractions. They're equal to the same. They have the same value. They just look different, but they have the same exact value, which is an equivalent fraction. Alright, and the last one is kind of like a two-part. Write a fraction with a denominator of 100. Oh, sorry. It should be. Sorry, write 3/4. Instead of a fraction, we're going to deal with 3/4. Write 3/4 with a denominator of 100. Okay, so, and then it says, then write that fraction as a percent, but we're going to do that second. So we have 3/4. We have to multiply it by some type of form of 1, and when we equal, the denominator is going to be 100. Again, I don't know what my numerator is yet, but I can deal with that later. So 4 times what number gives me 100? Now immediately when I'm dealing with 100, I think of money, and I try to think of, okay, what goes into 100 4 times, and then I just think of quarters, and a quarters were 25. So 4 25s, 25 plus 25 is 50, plus another 25, 75, plus another 25 is 100. So I'm multiplying by 25. And again, when we're multiplying across, or if our denominator is 25, our numerator must be 25 too, because we're multiplying by a value of 1. That fraction must equal 1, and we know that if we have 25 pieces, and we have all 25, it's equal to 1. When we multiply across, this you shouldn't have to go to the side and do side multiplication. You should know that if I have 25 cents plus another 25 is 50, plus 3 is 75. So my answer, 3/4, is also equivalent to 75 over 100. Then write the fraction as a percent. If you scored on a math test 75 out of 100, what would your percent be? 75 over 100 is equivalent or equal to 75%. And that one should be a little bit easier too, because when we play that math spoons game, you should know these pretty quickly. 75 over 100 equals 75%, because that would be a match during our game. Alright, in our lesson practice, down at the bottom, so the first 4, you're multiplying by a certain form of 1. So 4 times what number is going to give me 12? And that's 1. So the bottom number, the denominator, needs to be the same as the numerator, and you can check with your answer here. Alright, we will check these in tomorrow.